Hi there, my name is English, and this is my presentation on predicting diabetic status using classification machine learning, analyzing the impact of health indicators on diabetic status, and also demonstrating my accompanying Streamlit app. This project used a Kaggle source data set derived from the CDC's 2015 Behavioral Risk Factor Surveillance System survey. The dataset was modified to have a diabetic status focus. It had 21 different features that covered survey respondents' basic information, health, lifestyle, socioeconomic factors, which were used in determining their diabetic status, being the target variable I wanted to predict. The dataset initially was a size of 70,692 rows by 22 columns and came pre-processed for machine learning with pre-binary and ordinal encoding for the features. There were no missing values to fill in. The BMI feature had an extremely large range of values in it, so I plotted the values on a box plot to get a sense of the extreme outlier values, to then adjust the extreme minimum and maximum values to reasonable levels based off my own research of BMI to reduce noise in the model. I additionally engineered 2 new features based on existing health features to enhance the model's predictions. This classification machine learning model serves as a diabetic status prediction tool, as an early detection diagnosis and risk assessment tool, and this can be used in both medical and personal settings. The target audience includes hospitals and their healthcare professionals, diabetes researchers, health insurance companies, and for the average curious adult. This model allows medical institutions and professionals and the health-conscious individuals to have data-driven insights on diabetic status to help them make informed choices for themselves or somebody else. For the distribution of income level category per diabetic status, this visualization shows the relationship between income level category and diabetic status. As income level category increases, the proportion of people with pre-diabetic or diabetic status decreases, while the proportion of people with non-diabetic status increases. This shows that income level category has a noticeable inverse relationship with diabetic status, meaning that as income level goes up, the occurrence of having pre-diabetes or diabetes goes down. This visualization shows that the distribution of self-reported rating of respondents' general health across diabetic status. This shows that people with non-diabetic status self-reported a higher level of general health ratings compared to diabetic and pre-diabetic that self-reported a relatively lower level of general health ratings. People with non-diabetic statuses viewed themselves overall healthier compared to those with a diabetic status. This visualization shows the distribution of gender by diabetic status. It shows that females have a higher count for both diabetic statuses compared to males, making up a larger percentage of the gender feature. The difference between male and females for having a pre-diabetic or diabetic status is close between genders, while females show a higher multi-thousand advantage over males to have a non-diabetic status. This visualization shows the distribution of people who consume vegetables or not by diabetic status. Most surveyed people consumed vegetables, especially non-diabetics, and of those who did not consume vegetables, pre-diabetics and diabetics were a larger number of people in that grouping. This visualization shows the distribution of people who consume fruit by diabetic status. Compared to the previous visualization, there is a higher number of fruit non-consumers compared to vegetable non-consumers. Most surveyed people consumed fruit, especially non-diabetics, and of those who did not consume fruits, pre-diabetics or diabetics were a larger number of people in that grouping. This box plot visualization compares BMI ranges for the diabetic status groups. It shows that overall the median BMI is lower on non-diabetics than on those with a pre-diabetic or a diabetic status. The overall range of BMIs for both diabetic status groups has similar distributions, but on the non-diabetics have more outliers on the upper BMI value range compared to those with pre-diabetes or diabetes. Non-diabetics had a narrow interquartile range of BMI values compared to those with pre-diabetes or diabetes. Before creating 3 complex classification models, I needed to create a baseline model to serve as a comparison benchmark. This simple model tells the likelihood of picking the majority class of the target variable of diabetic status. The baseline model had an accuracy score of 50.0% due to the balanced amount of non-diabetics and pre-diabetic or diabetic classes in the data set. For my first model type, using k-nearest neighbors or KNN, this model's accuracy scores on the training and test sets beat the baseline model. The training accuracy score was 0.9% higher than the test accuracy score, meaning that this model was a little less accurate on predicting new data than while training. To get the best accuracy scores, a high K value was used. This model's strength was that it accurately predicted true positives, meaning it predicted someone who had a true positive diagnosis of pre-diabetic or diabetic status correctly. Its weakness was misclassifying true negatives as false positives, meaning it would misclassify a truly non-diabetic status person as someone with pre-diabetic or diabetic status. Let's see how the other models perform. For my second model type, I used logistic regression. This model's accuracy scores on the training and test sets also beat the baseline model, and they were also very similar to the KNN model's accuracy scores. The training accuracy score was only 0.1% higher than the test accuracy score, meaning it predicts nearly as well on new information as the data it was trained on. The logistic regression model has a similar strengths and weaknesses as the KNN model, as it also accurately predicts true positives, meaning it predicted someone who had a true positive diagnosis of pre-diabetic or diabetic status correctly. And its weakness was misclassifying true negatives as false positives, meaning it would misclassify a truly non-diabetic status person as someone with pre-diabetic or diabetic status. Let's see how the random forest model performs. For my third model type, I used random forest. This model's accuracy scores on the training and test sets also beat the baseline model and were right in line with the KNN model and logistic regression model's accuracy scores. The training accuracy was only 0.6% higher than the test accuracy score, meaning it was a little less accurate on predicting new data while training. The random forest model had the same trend of strengths and weaknesses as the other 2 models, as it also accurately predicted true positives, meaning it predicted someone who had true positive diagnosis of pre-diabetic or diabetic status correctly. Its weaknesses was misclassifying true negatives as false positives, meaning it would misclassify a truly non-diabetic status person as pre-diabetic or diabetic. In summary, all of the 3 classification models beat the baseline model score. They all perform similarly, with having slightly better training accuracy scores than test accuracy scores. They all had the same strengths of accurately predicting true positives and a weakness of misclassifying true negatives as false positives. The logistic regression model performed the best overall with the smallest difference between the 2 accuracy scores and had the highest test accuracy score, showing that it predicted on new data the best, and this will also be used in the Make Your Own Predictions page on my Streamlit app, which I will be showing next after this slide. For the next steps in improving this model, I would want to continue adding additional survey question responses from the original CDC survey to help improve the model's accuracy by giving it more information to help improve prediction accuracy and reduce false positives. Now to show off my corresponding Streamlit app that shows off this information in an interactive way and putting the logistic regression model to use. Welcome to my Streamlit app. This is the home page starting with page overview information and this visual about diabetes in a nutshell. On the left, there is a page selector with pages for home, data overview, exploratory data analysis, classification models and evaluations, and make your own predictions. On the data overview page, it gives an introductory statement about the data set and as well as information about the data dictionary. And at the bottom, 2 click boxes to show the actual data frame and to show the shape of the data. On the exploratory data analysis page, you can look at histograms, box plots, scatter plots, and count plots using plotly visualizations. You can look at histograms, box plots, scatter plots, and count plots. And any of these visualization types, you can look through the diabetic status hue. On the classification models and evaluation page, you can look at all the 3 different models we created of k-nearest neighbors, logistic regression, and random forest in specific detail. On the k-nearest neighbors page, you can select a k value and see its updated evaluated performance. You can see the results for the logistic regression model, and you can see the results for the random forest model, all with descriptions understanding the confusion matrix visualization. The highlight of the Streamlit web app is make your own diabetic status prediction page. We can use the 23 features into a logistic regression model to predict diabetic status based off user input. We can adjust sliders as needed to see what would happen if we change any and all of these 23 variables. To give an example, as I scroll, and for example's sake, just choose random values, we can see in the end that in this case we got non-diabetic. But one of the biggest variables that determines diabetic status is BMI. So if we choose a very high BMI of 100, which is huge, we're likely to change it to pre-diabetic or diabetic. And that was my Streamlit web app. Enjoy using it to figure out your diabetic status prediction. Thank you for attending my presentation, and please let me know if you have any questions on anything you just saw. And below is my Streamlit app link in case you want to check it out for yourself. Thank you.